Okay, in section 3.5, we'll look at quadratic inequalities. The book focuses on a graphing approach, but I'd like to give more of a focus on a table approach. And this is the way that I'd like you to solve using a table. For example, suppose that we have x squared plus 4x minus 5 greater than or equal to 0. I'm going to call the function f of x, x squared plus 4x minus 5 equals 0. And I'm going to set this equal to 0 and solve. X plus 5 times x minus 1 equals 0. So x equals negative 5 and x equals 1. Negative 5 and 1 are called critical numbers. That's not really terminology that you'll have to know right now, although it's really important in calculus. So be sure that you understand that the table approach in calculus, in my opinion, is a preferred option. Okay. We'll write the interval, the number chosen, the value of f, and then the conclusion. And above the table, I'll draw the number line and mark out the two critical numbers, which in order are negative 5 and 1. The intervals are negative infinity to negative 5 to 1, and then 1 to infinity. I need open intervals everywhere. The reason why I don't want any closed intervals is because, let me comment on that a bit later. I'm not going to choose any number I want in each interval. As a test value, number chosen is, say, it's negative 6. Okay, negative 6 squared is 36. Minus 24 is 12, and then minus 5 is 7. Okay, so 7 is a positive number, so I'm going to circle positive. 0 is a good number if I can use it. F of 0 is negative 5, and so negative 5 is negative, and 2 is f of 2 is 4 plus 8 is 12, minus 5 is 7. And so we're back positive again. Now notice how I've got open parentheses, open intervals everywhere. I'm not including the negative 5 or 1. The reason why I'm not doing that is because I'm allowed to select any number except negative 5 and 1. I already know what happens at negative 5 and 1. I get 0. 0 is not a positive or a negative number. So in general, I don't want to include those critical values in my table, but only the values that are around negative 5 and 1. Okay, so the set of all x such that x is less than or equal to negative 5 or x is greater than or equal to 1 would be my answer. Or you could just give interval notation. The only change is that because this is a greater than or equal to sign, I've got the function greater than or equal to 0. Well, numbers greater than or equal to 0 are positive numbers. And so I'm going to want the two positive intervals represented, okay, along with negative 5 and 1. On the number line, here's how that looks if we're asked to graph. Negative 5 and 1, you're going to shade those circles, and anything bigger than 1, anything less than negative 5. And just a note, if you write the set of all x such that x is greater than 1 but less than negative 5, that makes no sense. Negative 5 is not bigger than 1. Okay, so careful about that. Another way that the book describes this is to sketch a graph, and we've actually got a lot of the information already figured out. F of x equals 0 means that x is negative 5 and x is 1. Okay, so here's 1 and here's negative 5. If I choose 0 for x, I get -5 for y. Okay, here's 0 and -5. Okay, so these 3 points I've already got on the graph. If x is -2, -2 squared is, or let me just take the opposite of b over 4a. The opposite of b is -4 divided by 2a. 2 times 1 is 2. Okay, so -2. And then if I plug in -2 in for x into the function there, -2 squared is 4, minus 8 is -4, minus 5 is -9. Okay, so -2, -9, and I've drawn an axis of symmetry also. And I plotted some more points to show you that this is a parabola. And of course, now the question here is where is the function positive? Okay, well, if I'm greater than 0, y is greater than 0. If I'm equal to 0, y is equal to 0. If I'm less than 0, y is less than 0. So it's all about y, and where y is greater than or equal to 0. Well, it looks like if y is greater than or equal to 1, or y is less than, or if x is greater than or equal to -1, and or 1, and if x is less than or equal to -5. Okay, and I'm going to be positive on those ends, and I'm going to be negative here in the middle section. So I don't want that in my answer. Basically, you're getting the same answer here as making this table. Okay, here's another one. 2x squared minus 5x minus 3 less than 0. Okay, well, if I call the left side f of x and I factor f, f is going to factor nicely as 2x plus 1 times x minus 3. So x is -1/2 and x is 3. So I've positioned those two critical numbers on the number line in order, and I've got my interval, number chosen, value of f, and then the conclusion. Negative infinity to -1/2. -1/2 to 3, and then 3 to infinity are the three intervals. Number chosen in the first group, a nice number to use would be -1. If x is -1, we get 2 plus 5 is 7, minus 3 is 4. Okay, 4 is a positive number, and the conclusion, all I write is, you know, if the value of f is positive or negative, of course. If x is 0, I get -3, and that's a negative. And if x is 4, 4 squared is 16, times 2 is 32, minus 20 is 12, minus 3 is 9. 9 is a positive number. Okay, now in the question, I'm asked, where is the function less than 0? Okay, well, numbers that are less than 0 are negative numbers. So I need the negative interval to be represented because that's what's given me a positive result. Positive meaning true result. Set of all x such that x is greater than -1/2 and less than 3. And -1/2 to 3, I'm using interval notation in the table, so when I use interval notation when I get my answer. And here's if you have to graph on the number line. Okay. Another example, 4x squared minus 6x minus 9 equals 0. let's see here. So that should be a plus 9. Plus 9. And so plus 9. Let's see here. 4x squared minus 6x plus 9 equals 0. Okay. X is equal to the opposite of b, which is 6, times the square, plus or minus the square root of b squared negative 6 squared is 36 minus 4 times a is 4 times c is 9, divided by 2a, 2 times 8, 2 times 4 is 8. 36 minus 144 gives me negative 108. So I got 6 plus or minus the square root of negative 108 divided by 8. Now, whenever you run into the square root of a negative, there is no table that you're going to make. No table. You're just going to try a test number, say it's 0. 0 is always a nice, comfortable number that I use in situations like this. So if x is 0, then I get 9 less than 0. 9 is not less than 0. 9 is greater than 0. So what that tells me is that no solutions are going to be found there for the equation. Okay, there is no table that we make. Okay, no table like the ones earlier. Suppose that I switch the sign. Okay, well, everything that I've done here is going to be the same. I get 6 plus or minus the square root of negative 108 all over 8. Okay, now if I try a test number like 0, it is true, 9 is greater than 0. Okay, and so in that case, I would write all real numbers as the answer. Okay, meaning that any number that I select is going to be a true statement. In this situation, any number that I select is going to produce something that's false. Okay. The homework is on page 172. Be sure to look at those problems for me when you get a chance. And right now we're done with chapter 3, and we'll get into chapter 4 in the next section, next video.